Hey guys, how you doing? This is Coach Scott, Coach Scott's Chemistry, and I got a request on Remind. Thank you. I won't say who it was. That they had a question on one of the summary worksheets about, especially about number 12. And I know this is not an easy way to do this, right? And we will continue to talk about this more and more and more. All right. In fact, we'll come back to this whole subject. But again, what we're really trying to figure out is what phase change is. And this question, let's read it. How much heat or energy is required to convert a mass? Let's go up here and get this one. Where are you at? There you are. All right. A mass of 18 grams or 1 mole of ice. And we're going to convert it a little bit, right? We're going to convert it. We're going to convert it from ice at minus 5C. We're going to, and think about what we're going to do. We're going to melt the ice. We're going to heat up the liquid, all right? And then we're going to boil it, and that steam is going to go to a temperature of 111 degrees C. So let's think about where we're at with this, right? So we start at minus 5C. We're going to throw heat into it, all right? And then it's going to start to melt, all right? And it's going to melt. Then it's going to, after it's all liquid, it's going to continue to rise until it gets to 100 degrees C, or the boiling point of H2O. And it's going to boil away. I just boiled some eggs this morning, right? So that water was boiling away. Then it's going to continue to increase until we get to 111 degrees C. So that's the first thing I should see when I start doing a phase diagram. I need to see this type of picture, right? And that's what we're doing, just drawing a picture of what we're seeing. So let's see. This is our starting temperature, and that is minus 5 degrees C. We know water melts, or liquid H2O melts at, let's see what temperature that is, 0 degrees C. All right, then we know it's going to boil at 100 degrees C. And if we don't know it, it's here in the problem. The freezing point of H2O is 0 degrees C. Boiling point is H2O is 100. So I need to label those. Then our final temperature, all right, is right here. That is what? That is 111 degrees C. Okay, got that. Now we've got an idea of what we've got here. Now, to get the total sum of what we're trying to get, hi Brian, to get the total sum of what we're trying to get, let's get out of that. Okay, we've got to think about what we've got here. All right, let's change the colors just so we can see it. Let's go red. So right here, the rise stops, and then the is converted here. We converted the liquid, or we're converting the liquid to steam there, or to gas. Then all the liquid is converted there. So we've got 1, 2, 3, 4, 5 different phases. Now what I like to do is identify the phases. You can do what you want. So that would be Q1. That would be Q2. Because we're doing a phase change. And that's just a different one there. Then we've got Q3. There we're heating it up, changing the temperature. Here we're converting from liquid to gas, Q4, Q5. And I think you should be able to understand what's going on at those different phases, or those different changes, right? Now, if you get that, you pretty well got it, all right? You get the understanding, you've understand the concept. Now, let's take it a step further. What formulas can I use here, all right? We've studied QMCAT equal MC, which is specific heat of that phase, delta T, which is the change of water. We've also studied how to calculate the molar heat of fusion, which is where melting occurs, and that is Q of fusion, FUS, equals the delta H, and we call this the molar heat of fusion, FUS, times the number of moles. And again, right now in our career, I'll give you how many moles you've got, which is 1 mole. And then what goes on at this stage right here, okay, here we're changing from solid to liquid. Here we're changing from liquid to gas. There we're vaporizing. So we call that the Q of vaporization. And at this stage, I want you to understand what we're dealing with here, right? And this is what's going on. Okay, and that is delta H of vaporization times the number of moles, which again at this stage I'll give you. So if I want to go to the last step and calculate what the total heat energy is, then I've got to do some more calculation. At Q1, okay, let's go over here where we're at. There we are. Let's change this color. Well, let's go to a gray. Where are we at? There we are. All right, so Q1, all right, we're at that phase right there, and that's where there's a heat change. We need to know mass. The mass is, let's see, 18 grams. So I can just plug that in because we've got 18 grams. And then I've got to pick out the right, C, or the right specific heat. Okay, now we're dealing with ice right now. So that's going to what I want to choose, 2.05. 2.05 joules per gram per degree Kelvin or C, because we're dealing with magnitude. It really doesn't matter, okay, whether I use C or K, as long as I'm consistent. All right, so if I take this, let's see, we started at -5, our final temperature is 0. So if I take 0 minus -5, I'm going to have final minus initial, I'm going to have a +5 degrees magnitude. Now that can be C or it can be K. If I convert it and I subtract it, I'm going to get K. So I can do that. And I put that degree sign. That's not exactly correct. So the first Q, all I got to do is multiply. And I'm going to tell you on a test, because this will take a long time, if you do this part and you identify where you're going to be doing this, you've got the problem. Okay, you're there. So I'll use my calculator. 18 times 2.05 times 5. All right, so the amount of joules here would be 184.5 joules. Because I canceled out everything, right? And that's what I have left. Now to find that second phase, there I'm dealing with the heat of fusion. So I'm going to use that formula. So Q2, let's go back to this one. So Q2 would be the delta H of fusion, which is, from my data, 6.02 kilojoules per mole. Kilojoules per mole. And that -1 means it's in the denominator, times the number of moles, which is 1. So Q2 would be 6.02 kilojoules. I'm going to go ahead and convert that to joules, which I know, since there's 1,000 joules in a kilojoule, all I've got to do is move the decimal over 3 places. 1, 2, and there's a 0 there, 3. So that's 6,020 joules. There's my Q2. Q3, I'm going back to a QM cat problem. Okay, I know I'm going from 0, right, to 100. So it's 100 minus 0, that's 100, right? Let's go ahead and change this color here. Let's go ahead and change that to, let's go to that color. That's a pretty color. So my Q2, didn't mean to do that. That's okay. Q2 is 18 grams again, because I have not lost mass, times the, which one? The specific heat of liquid water, which is 4.18. 4.18 joules per gram per degree K, or really per degree C. And I already calculated my delta T, because I can do 100 minus 0. That's pretty easy. And then let's cross through those. I got rid of my grams. So that's going to give me the number of joules that it takes to increase the temperature of 18 grams of water, right? 100 degrees. 0.18 times 100. I'm very popular this morning, can you tell? So I calculated 7,524 joules. Q2 equals 7,524 joules. Now I've got to look over here at the Q. That's Q2. Oh, I said Q2 there. I was wrong. Sorry. That's Q3, because there is the increase of the temperature. That area right there. All right, and then Q2 was right there, and then change that color. Q1 was right there. Now we got to calculate Q4. Now what is Q4? That liquid is boiling away, and it's taking energy to boil away that 18 grams of water. So let's go down here. I'm going to use the orange here. All right, so here's Q4. So we've got to figure out how much energy it's going to take. All right, I'm going to turn those notifications off when I do this. Q4, then that is what? Vaporization. So now we're going to use the molar heat of vaporization of water, all right, which is what it is. Q4 delta H. I use that just as a symbol for what it is. Okay, times the number of moles, and it is 40.7 kilojoules. We'll do my math first. Equal 40.7 kilojoules per mole. I'm doing this -1 type deal just to get you used to it. All right, times the number of moles, which is 1 mole. Where did I get that? It was in the problem. It was in the problem. 1 mole, or 18 grams. So I don't have 1 times 40.7 is what it is. It's 40.7. So Q4, and I'm going to go ahead in my head convert that to joules. Again, I know there's 1,000 joules in 1 kilojoule, so all I've got to do is move the decimal over 3 places, and I do. So it takes 40,700 joules to convert that to steam. Now, the last one I've got to do, and this is it, guys, is I've got to see how much energy it's going to take, purple, let's do purple, to move the temperature of that vapor 11 degrees. 111 minus 100, that's 11 degrees. So that would be my Q5. All right. And there I'm going to use QM cap. My Q was, let's go back, my M was 18 grams, so that stays the same, 18 grams. We didn't lose any mass. 18 grams times the C. Now I've got to pick the right C. Here I'm dealing with steam. That's 2.8 joules per gram per degree C. What was that? 2.08. joules per gram. That's 1 per degree K or per degree C times 11 degrees. And we can call that K or we can call it Celsius. It's the same magnitude. Where did I get that from? Right there. Where did I get the 18 grams from? It was given in the problem. Where did I get the 11 degrees? 111 minus 100. All right, so now I've just got to do math. Hit my calculator. 18 times 2.08 times 11. And I get 411 joules. Q5 equals 411.84. I'm not rounding up now yet. So if I want to get my total energy, I'm going to take Q1. I'm going to add it to Q2 because Q1 is where it's going. It's increasing from -5 to 0. All right, and it's Q2. That's where it's melting. I'm going to add it to the increase in temperature from 0 degrees C to 100 degrees C. So that's Q3. Then I've got to add it to the energy required to boil the water. That would be Q4. And then I got to add it to Q5, which is the energy required to heat it at 11 degrees from 100 to 111. And that's going to give me my Q total or Q sum. Total. So to find Q total and to totally answer this problem, all I've got to do now is just add up my numbers. So I'm going to add 184 from Q1.5 plus Q2 6020 joules plus Q3 7524 joules plus 40,700 joules plus Q5 411.84. I get the number of, where's my thing? Here it is. So my Q total is 54,840.34 joules. Now this is where the sig figs come into play. Okay, the most significant figures I've been dealing with is 3. So I'm going to tell you what I'm going to do. I'm going to convert this now to kilojoules. So that means there is 1,000 joules, so I'm going to divide by 1,000, which means I'm going to move my decimal over 3 times. And if you put this down, I'd probably maybe give you credit. But don't chance it. So it takes 54.8, because what I did is I rounded, all right, this decimal, or rounded to this place, so I'd have 3 places, kilojoules. I could also record it in joules, but that means I'm going to do scientific notation. So another term for Q total would be 5.48, 3 significant figures, times 10 to the 4th joules. Because I moved my decimal over 1, 2, 3, 4. Either one works. So there's that problem. Also, I'm going to work the cooling problem, okay, on your worksheet. I think it was E. So I'm going to do that next, and we'll post it up here. And hopefully this will help you guys out. Thanks. Bye.